We're going to hop into making that rollerball script, and we're going to make our own. So if we go back into Assets, we can right-click and do Create C# script, just like before. And I'm not going to call it exactly rollerball. Maybe like roller marble. Definitely not a ripoff. Okay. We can hop into that. Cool. Okay. So we have our roller marble. So, a few things we need to do here. Let's just go over the game plan in our head of what we want to do. So we have a ball, and we want to push it in a direction based on whatever the player is pressing. So, the player is pressing the W or S keys. We want to push it forward and backwards, respectively. And if it's pushing left or if they're pushing A and D, we want to push it left or right, respectively. And as a general statement, that's pretty much all that we need to do. So let's go over and do that. So first off, let's do a few things. So first off, let's do void. I deleted everything already, so we start from a fresh slate. Void fixed update, and then an open parentheses, close parentheses. Cool. So in this case, we're using fixed update instead of update. This is an implementation detail of Unity. It's just a quirk. Fixed update is used for things related to physics. That's pretty much the deal. So it's just to make it play nice with how Unity handles their physics and update in time.
So do we need to get rid of update in order for fixed update to work?
No, you can do both. Right now we're just using fixed update. Cool. So if we have fixed update, so now what we want to get is we want to get a value that represents going left and right and a value that represents going up and down. Luckily, Unity provides us some great methods to do this. So let's type in float. If you're from CS31, you're probably using doubles. This is a lower precision version, and this is what Unity relies on. So float, and let's do horizontal, and then float vertical. So this is going to represent our horizontal movement and our vertical movement, respectively. And the way this is going to work is Unity is going to give us a value from -1 to 1, representing how forward or how back it's going. So if I write this down, we are going to have something like this, where we have our this. This is going to be 1, 1, -1, -1. And then let's say this is vertical. This is horizontal. Wow, that's a really bad R. Horizontal. Okay, so we want to get these two values, because if we have them, then we know which way to push our ball. So how do we get them? So the nice part is that Unity is going to give us a nice thing, that when we press W, it's going to give us a 1 in vertical. When we press S, it's going to give us a -1 in the vertical. And we press D. Let's put it up here. We press D, it's going to give us that. And we press A, it's going to give us that. Or each of the respective arrow keys. So luckily, we can just get this 1 to -1 value on each of these. That lets us know where we need to push it. So this one, for instance, might be like 1 in this direction and 1 in that direction. So diagonally forward. Cool. So the way we're going to do that is we're going to say horizontal equals input dot get axis, and then inside of it, you're going to write the string horizontal. So this is provided by Unity, and Unity has actually been nice enough to define some default axes for us, and this axis is the horizontal one. So say, for instance, you were maybe using something like an Xbox controller or something like that. The left stick of that Xbox controller would actually work just perfectly with this getAxis function as well, along with your A and D key and your left and right arrow keys. So then we'll do the same thing with vertical. So vertical equals input dot getAxis vertical. Cool. So if we want to see how that works, let's do debug.log, and let's just say horizontal plus a space, and then plus vertical. So this is just going to let us see at every fixed update, which is, like, if you guys want to know, fixed update runs, I think, 50 times a second, something like that. So 50 times a second, it's going to log that. So let's build that, and let's go ahead and start testing. So we have our own roller ball. I'm going to take this roller ball. I'm just going to turn it off for now by clicking this. And instead, we're going to go create, and let's create a 3D object and create a sphere. It's going to spawn it in a really random location because Unity is awesome, and you're just going to reset its position and move it up a little bit maybe. Cool. So now we have a sphere. I'm going to drag the pink onto it. If you if you click on this cog at the top right, can you guys see that? Yeah, it's a little bit tiny. And then you click reset. So if we add on our what is it, roller marble? Our roller marble script. Then if we press play, let's see what happens. So you see we have our project in our console. I'm going to open up my console. And now if I start pressing things, you'll see that it's working. So when I press left, it's -1 and 0. When I press right, it's 1 and 0. When I press up, 0 and 1. When I press down, 0, -1. So it's behaving as we expect, and everything in between. So for now, I'm going to delete this debug log. You can also comment it out. So comments are the same as in C++ for all UCS majors, like that.
Tyler, why are you using floats for horizontal?
Because Unity doesn't do doubles. That's a game engine optimization. Cool. Okay, so now we want to translate these into a force that we put onto the object. So how do we do that? So we can sort of think as our force, if we're looking down, this is our ball right here. This is our A and D axis, but we can also think of this as our x-axis. And we can think of this one as our z-axis. And the reason we could do that is because if we go back into Unity, and if we look at our ball from above, like that, you can sort of see our blue axis is z, and that points forward. And our red axis is red, and that points to the right. So that corresponds perfectly with the x and z right there. And since we know that, we can actually create, similar to how we did before, a 3D vector that has these values. So our vector, let's say we have like 3 components in it, x, y, z. What we're going to do is we're actually going to make this one a big 0, because we don't want to push it up or down any. We just sort of want to push it along the flat plane that is the ground. So we just have to construct this and push the ball with it. So let's do that. So let's make a new vector 3. So vector 3, let's say force vector. Sounds good to me. And the way we're going to create this is you type in new vector 3. And inside of it, we'll say for our x value, let's use horizontal, comma. For our y value, 0. We don't need that. And for our z value, let's use vertical. Awesome. So that should be creating a vector that might correspond to this. So this one right here may be something along the lines of 1, 0, 1. And now all we want to do is push it with that velocity. So we're going to do this in a slightly inefficient way, but bear with me. So what we can do is we can do get component. Actually, yeah, get component, rigid body. And we're actually going to put a this in front of it. You don't need to, but I think it is instructive. Maybe actually, can we do that? I don't know, we'll see. Does it allow that? Yeah, it looks like it does. Okay. This dot get component rigid body. So we're going to get the rigid body that's on us, And remember, if we go over previously, the rigid body is what allows us to do physics. It's what we caused to sleep earlier to stop the ball from moving. So now we're going to get this rigid body component, and we're going to say dot, and we have a bunch of cool things here. It always tempts you right at the beginning with add explosion force right at the top. It's tough. You have to resist the temptation. Let's go down to add force regularly. And then inside of that, you're just going to put in our force vector. Cool. So the reason I say this is inefficient is because we're calling getComponentRigidBody on every fixed update. We don't need to do that. We could actually store that value somewhere else, but this is the easiest way to write it. So let's test it out. So if I press play, what's going to happen? It's going to start throwing errors at us. Really pissed. Missing component. There's no rigid body attached. Yeah, we messed up. So we need to put a rigid body on this object, otherwise Unity's not going to know what to do with it. So if we have our sphere, I'm going to call this marble. Let's go ahead and add a rigid body. So if we click add component down here, and type in rigid body, there it is. It popped up, and we can just click it, and there we go. We now have a rigid body on our object. So let's test it out again. Let's see how it works. Whoops. And boom. And if I press any of the keys, you can see it's very slowly moving. It's making its way along, you know? It's taken a while. Yep. So, first issue to tackle. First issue to tackle. The ball is really slow. Let's speed it up a little bit. So let's hop into our script, and let's go and make a public variable and say public float, let's call it speed. And then on our force vector down here, we're just going to say times speed. So we're actually going to take this and we're just going to multiply it by this speed. So the way that multiplying vectors and floats work is we would say something along the lines of this times like, what do we call it, speed? S? Ends up just equaling like x times s. This will still be 0, but it'll be 0 times s, and then z times s. Is that visible? So it's just like for every component in the vector, we just like scale it in that direction. Cool. So let's test that one out. If we go back to Unity and we look at our roller marble. What's up?
You need to put a number for speed.
Oh, I can. If you go back in the Unity editor, you can see right here in our speed, we can actually access it and change it however we want. So I'm going to go ahead and change mine to 4,000 just to make sure it's working. Let's see. Okay, and yep, definitely works. So it launched off. Another thing you notice, our camera doesn't follow our ball anymore. That's because it still has reference to the old one. But the speed is definitely working. I'm going to tone it down a little bit, maybe go to like 5. And that works pretty well. I'm liking that. Perfect. So the nice part is that when you define these public variables, you can sort of let the designer, or maybe someone who's not you, determine what the value should be on it. So maybe you think that a speed of 5 is really good, but once you start building your experience, you realize that a speed of 10 is a lot better. This is great because you don't need to go into the code. You don't need to touch any of it. You can just say, within the Unity editor, it's 10 now. Something that's even nicer is that if you press play, and we're in our game, and I'm going, and I'm like, okay, this feels pretty fine. I can actually go in and just modify the speed right now while we're playing our game. Let's make it like 13, something like that, and now it's going to move a lot faster. So you can really easily modify values while you're in the editor, while you're playing. But, and this is a big but for everybody, any values that you change while you're in play mode will not get saved. So when I unpress play right now, this goes back to 5. So anything that you change in play mode is pretty much just for testing. But yeah. So there we go. So we have a ball that moves around. If we want to make it a little bit better, I might go and snag my main camera and make it follow the marble instead, just so we get some better action and feels a little more normal now. Cool. So yeah, so now we have our own character that we've all programmed together, and it works relatively similarly to how the other one does.